Hi everybody. Tonight's video is going to be about points, lines, and planes. So these three things, points, lines, and planes, are called undefined terms because they can only really be described by examples. It's like one of those things where somebody tries to ask you to try to explain something and you really can't explain it besides just being like, that's what it is. So point is a point, like that's the best way you can describe it. It doesn't really have much more of a definition or description than that. It's not like a specific size or anything, it's just a point. So what we're going to see a lot is a point is just going to be marked by a dot, and usually it's going to have a capital letter with it. So for this case, we'll just use point P. Okay, so usually it's a little dot on a diagram, and then there's a capital letter. If you see this written out in a sentence, this point right here would be referred to as point P. And we're going to use the capital letter also when we're writing it out in a sentence. A line is an infinite set of points that are in a line, or in other words, collinear. So when we're diagramming lines here, this is technically an infinite number of points. So I could keep writing points forever. But usually we have at least two that define this line. And again, these are all points on here, so we're going to use capital letters. The thing about a line versus a line segment, which we'll talk about later, a line always has two arrows on the end because it goes on forever. So we're thinking like if we're going to relate this to a map, a point is a point on the map, like a city or something like that. Line is like a street on a map that would continue on forever. So in this case, I have line AB, or I could call it line BC, or I could call it line CA, as long as I'm using the letters, the names of the points that are on the line. Sometimes you'll also see a line described by a lowercase script letter that's off of the line. So you might see a line and then like a lowercase script L. So I could call this line L if I was writing that out in a sentence. I could also call this line AB or line BC. Another way to write that is take two of the letters, and it doesn't matter which order. You could go BA, CA, whatever. And you're going to take two of those letters, capital letters, because they're describing points, and then you draw like a little line above them, making sure that you use those two arrows, one on each end. So that's another way that you might see this line described or written in a sentence. And the third thing that we're going to talk about is a plane. A plane is an infinite set of points that are all coplanar, so they're all on the same plane. This is like the actual map, the piece of paper that the map is printed on. If that were to go on forever in all directions, that would be a plane. This plane is usually defined by a capital script letter. So you might see something like script R to describe this plane. You might also see like three different points that are on this, like X, Y, and Z. Okay, these are all capital letters. So I could call this plane R using the script R, or I could call this plane X, Y, Z, and I would just use those 3 points together. I'm going to use 3 points to describe a plane instead of 2 points to describe a line. It just makes it, helps me distinguish between the two. So I'm not just going to use 2 points to describe a plane. I always want to use at least 3. Or I could use the script capital letter. That's going to distinguish between point, which is just a regular type capital letter as well. So those are the 3 ways that you might see, or the 3 things we're going to talk about, and some of the different ways you might see them written out or referred to when we are going through some example problems. Now, all points, lines, and planes are contained in space, which we'll define as a boundless 3-dimensional collection of points. So anything is always contained in space. And we can have all kinds of lines, points, planes, and they can all go in various directions. So here I have 2 planes, one that's going vertically and one that's going horizontally, if you can picture this. So this is going like straight up and down. This is supposed to be flat going across. And so there's all kinds of things that can be on these two different planes. So let's refer to this as plane P, and we'll refer to this as plane Q. And then I can have points and lines intersecting all over the place. Where these two planes intersect, where they cross each other, would actually be a line. It's like two pages. If you fold a page in half, technically that becomes two different planes because they're one side is going one way and the other side is going the other. Where they intersect on that crease is actually a line. So these planes here, they intersect on this line. We can call it line M. That's kind of a lowercase m there in script, remember? And then there's all kinds of points that are on this line. Let's call this point D and this point C. Point D and C are on line M. They are also on plane P, and they also happen to be on plane Q because of the fact that M is the intersecting line between P and Q. So when we're dealing with all of this, we're going to be looking at different things that are collinear, so D and C are on the same line, coplanar, they're both on the same plane, P, and then there can be some points that are not coplanar. So maybe I have a point down here on plane Q, let's call that point E, and then on plane P, I have F, and so these 2 points are on 2 different planes, so that I wouldn't consider them coplanar. So they're only coplanar if they're on the same plane, or collinear if they're on the same line. So those are just some of the different things that we'll see when we're working with points, lines, and planes, and some of the different arrangements that we could possibly have. The last thing that we'll talk about is sometimes with these objects, we say real-world objects model them. So they can model points, lines, or planes. So back to our original examples about a map, here we're thinking to ourselves, what are some other real-world examples that model these different forms? So if you're thinking about the edge of your desk, so just along the edge, that would model a line, right? Because it's just a straight line. It's not complete. It doesn't go on forever, but it's just the edge. It's just a straight line collection of points. The whole top of your desk would model a plane, right? Because it's a whole flat collection of points. Again, doesn't go on infinitely, but that's kind of the idea, that it's a flat collection, and all those multiple points would all be coplanar. And then if you think of the piece of gum stuck to the bottom of your desk, that would be more of a point, right? It's just one little point in space stuck to the bottom of that plane, so it's just one point on the plane. And we can also talk about other things, like in the previous diagram, we had that line M that intersected the 2 planes P and Q. So like the binding of your notebook, for example, that would be a line at the intersection of multiple planes, right? So each page of your notebook would model multiple planes. Each page of your notebook would model a plane, and then having them all intersect at the binding of your notebook would kind of be like the line of intersection there. So bring these notes with you to class. We'll do some examples and some practice problems talking about naming different lines and different planes and where they intersect, and talking about other examples of modeling points, lines, and planes. Have a great night.